dimensionality reduction. So clustering does exactly what the name implies. It clusters similar data into groups. And dimensionality reduction can reduce the number of random variables and the number of dimensions in our data. So if you look on the left there, that's a visual representation of clustering where similar data is grouped. And then on the left, or I'm sorry, on the right, you can see the first very colorful image is multidimensional and then becomes flattened. So I'm going to focus on clustering. So clustering is good for exploring the data, for pulling out those relationships and being able to see what sort of groups might exist in the data. So clustering generally is done by, clustering groups instances together so that instances in the same group are more similar to each other than to those in other groups. So this is generally done by calculating the distance between data points. So what distance calculation you use depends on both the data set and the algorithm you're working with and what sort of end result you're going for. But for example, you could use the Euclidean metric, which calculates distance based on the Pythagorean theorem. So there are quite a few clustering methods, but I'm going to talk about k-means clustering. So k-means clustering has 3 steps. The first step is to choose those initial cluster centers. And the next 2 steps are looped over. The first thing that happens is each data instance is assigned to the cluster it's most similar to, and then the cluster center is recalculated to the mean of what the cluster is after the new data is added to it. So basically what this does is we put the data into groups, we take the mean of that group, we have a new cluster center then, and then we can add data into the group it's most similar to based on that new cluster center. So it's basically just a way of iteratively reorganizing your data to pull out patterns. So it's up to you to decide how many clusters you want the clustering algorithm to create, which, while being very efficient, can deliver poor results if you choose the wrong number of clusters. I'm not going to cover ways to choose clusters right now because there are quite a few different methods, but generally the more familiar you are with the data set, the better decisions you can make about how many clusters to have. So working with that car evaluation data set again, let's go through the clustering process, which again is very simple. So the first thing we do is we create our clustering object. So I'm using the k-means clustering object, and I've chosen to make 4 clusters because I already know that there are 4 labels in our data: unacceptable, acceptable, good, and very good, which is sort of cheating.